So hello guys, again welcome back to Helpful Code eLearning. This is very important question. Why fundamental data types are immutable? Okay. Fundamental data types means we are talking about the integer, we are talking about the float, we are talking about the boolean, then a string, then complex. Okay. Why these fundamental data types means your predefined data types are immutable. So I'm just going to explain this concept in terms of memory management. Okay. So let me check how this memory management we are going to check here. Okay, so I'll just explain that way, and this is going to help you to get understand. So understand guys, here if I'm going to provide the value, like I'm taking a val1, this is the first variable. Okay, if I'm providing the value like 5, and second time I'm taking a different variable, but if I'm going to provide the value same value, okay, if I'm going to provide the same value like 5, now if I'm going to check the address of this both the variable, and you know that in the previous lecture we have already covered that how you can check the address, how you can return the address using the id function. So if I want to check that right now, if I'm providing the value and the same value to a two different variable, so will I get the same memory address or we will get this different memory address? So practically we are going to check here. Okay. So print function, this time id, we are going to check val1. Okay. Similarly, print id function, we will check val2. Okay. So let me run. And you can check, you can pause the video and you can check here this address and this address, both the address are same, 140713657420344. The same value we are getting 420344. Okay, so this is very clear guys. Once you provide the value to the first variable val1, so next time when your interpreter, because your interpreter is executing line by line, so your interpreter has reached to the started from the first line, so it checked that okay, val1 wants a value like 5. So what is the job of your interpreter? Means what is the job of your Python virtual machine PVM? It will check whenever you're going to assign the value, new value, when you're trying to assign in the variable. First of all, it will check that is this value is already exist in any other variable. If it is already exist, so it will assign the same memory address area. Okay, if it is not exist, then it will create the separate memory. Like here, for this particular variable, it has created a separate memory, and that memory address has assigned to this variable. Okay, but in the next time when you're trying to assign the same value, okay, so this time your interpreter again will check, because this is the common job, this is the same job your interpreter will perform repeatedly for each and every variable. Okay, it doesn't matter how many variable you have declared. So it will check again that is this 5, this value is already exist in any other variable. Yes, it is already exist, because first time this 5 is already assigned to the 5, sorry, to the val1. So the memory is already created. So same memory address, the same memory address is going to assigned to the val2 also. Means we can say that val1 and val2 both are focusing on the same variable. Okay, here we can say that like uh, in this way, like val1. Okay, this val1 is also focusing on same memory area, like for example 5. Okay, this memory area. And the val2, if we are talking about, so val2 is also focusing on the same memory area. Okay, means we can say about that. Okay, or I'm just going to cut here or paste here in the different manner I'm going to show you. Right. So val1 and val2 both are pointing to the same value. Okay, because this is the job of your interpreter, that your interpreter, your Python virtual machine will always will check. Okay, if you have taken the value like 5 first time, so it will create the separate memory if it is not exist in any other memory area, and it will assign the memory address to the val1. In second time, when you are trying to store the 5 in the val2, so it will check, okay, that val2 you're trying to assign. So if the values already exist, the same address of this value will be assigned to the val2 also. Okay, this is what way we can say that. And if you provide the different value, okay, different value, like if I'm using the uh, val3, and this time if I'm providing the value like 3 something, and let me check the output. Let me check the output. If you are providing the value like a variable like val3, so let's check the output. Uh, yeah. So again, you can check the first two variable, val1, val2, value is same. That's why the memory addresses is also same. Okay. So indirectly, I just want to tell you that it is assigning the same memory address to the val1, or it is same memory address to the val2 also. But in val3, we are assigning the different value, that is a 3. Again, your interpreter will check this 3, this value, this 3 is already exist in any other memory or not. Okay. If it is not exist right now, as you can see that you haven't used this 3 in any other variable, so this 3 doesn't exist. So this time your interpreter will create a separate memory for this value, and that memory address will be assigned to the val3, and that's why you're getting a different address. Okay, you can check the last last 3 digits, so you can check here that you're getting a different memory address. This is what a way to get understand, guys, that why fundamental data types are immutable. Okay, because if you provide the same value, the job of your interpreter is fixed constantly. Every time it will check whenever you create the new variable, new value for the new variable, so it will check that this value is already exist in any other memory area or not. If it is already exist, same memory area will be assigned to the variable. If it is not exist, then in that scenario it will create the separate memory, and then that memory address will be assigned to the variable, like it is happened here. Okay, here first time we created the value 5, val1 we have assigned the 5. Your interpreter has checked is this value is exist, no, so created a separate memory assigned to the val1. Second time when you are trying to assign the value like 5 to the val2, this time your interpreter again will check is this value is already exist, yes it is already exist. So the same memory address, this memory address will be assigned to the val2 also. Okay, means your interpreter will not going to create the separate memory for same value. Okay, separate memory for same value, it is your interpreter is not going to create. So when you provide the different value, again it will check is this value is already exist in any memory, no, so this value this time your interpreter will create a separate memory, and that memory address will be assigned to the val3. So this is all about the fundamental data type, guys. I hope you have understood very well about this memory management technique. There is some advanced memory management concepts are also there, but right now I'm just covering the basic things. So here you're just getting a basic fundamental, but try to understand, okay? Because this is very important. If you change the value here, so then it will create the separate memory address because it's a variable. Okay, fine. So thank you, guys. We'll see you in the next lecture.